part A by plugging the 3 into the g function. When we do that, and I'm going to kind of do it in my head, 2 times 3 is 6. 6 minus 7 is negative 1. Negative 1 over 3 will just keep negative 1/3. So it's f of negative 1/3. Now I'm going to plug negative 1/3 into the f function. What is 3 times negative 1/3? Yep, 3 times negative 1/3. If you guys need help with that, use your calculator. It's negative 1. Negative 1 plus 7 is 6. 6 divided by 2 is 3. So what happened here is what happened on that last problem on last night's homework. F of g of 3 gave us 3. And without doing it again, I'm going to say, if we flip the order, actually let's do this. This is a good task. G of f of 3, if I plug 3 into f, what's 3 times 3? 9 plus 7, 16 divided by 2, 8. So now I have to do g of 8. 2 times 8, 16 minus 7, 9. 16 minus 7 is 9. 9 divided by 3, 3. So it happened no matter which way we did it, f of g of 3 or g of f of 3. They both gave us 3. So after the composition of functions, we're getting the same thing. And without doing it, I'll promise you that that's also going to happen for part C. So f of g of negative 2 is negative 2. And that's also going to happen for part D. When that happens, no matter which, sometimes it happens in one order, f of g of 3 coincidentally, and when you flip-flopped it, it wouldn't happen again. But if it happens both ways, okay, and over and over again, that means that these functions are inverses of each other. Meaning they're kind of machines that, do or undo each other. So think about like in a factory. If you kind of put a bunch of materials into a machine, some leather, some string, and then out popped a football, right? The machine turned all your materials into a football. So that's machine A. Well, then you have machine B that you can take that football and put it into, and it unsews the football and out pops the original leather and the strings that you started with. Does that make sense? So they're machines that sort of undo the other's work back to your original components. So I write this as a little star here. F and G are inverses of each other. This is a key point. Then point AB on f of x will result in point BA on g of x. So circle that. That's a key idea that comes up over and over again on the regions. We have to learn about inverses, and this is the first key concept. Okay? So exercise 2 speaks to that. If this point lies on the graph of f of x, then which of the following points must lie on the graph of its inverse? So which point here just flips them, AB to BA? Option 3, 5, negative 3. Agreed? Negative 3, 5 would go to 5, negative 3. It just took those two coordinates and flipped them. Okay? Inverse notation. If this is your original function, the inverse is written like this. So f of x is the function, then the inverse is f. It looks like a negative exponent, but it's not technically an exponent. It's a superscript. Okay? Subscripts kind of are written little here. This is a superscript. It's not an exponent. It does not raise that to the negative first power. When you read this, you say the inverse of f of x. This is the function f of x. This is the inverse of f of x. Is that clear? You have to get used to that notation because you won't always see the word inverse. You'll see the notation instead. All right? Writing the inverse function, again, is something we will do over and over again. This will be a flashcard eventually. There's a list of steps that you do, and here they are. Okay? The first thing we do is when we take the original function, written in function notation, we change the f of x to y. And that's just because y and f of x mean the same thing. So y equals 3x minus 5. Step 2, swap the x's and y's. So now instead of y equals 3x minus 5, I have x equals 3y minus 5. Side note, this whole swapping of the x and the y is the reason this happened as well. Didn't we swap the x and the y coordinates? Yes? So there's a connection there. The whole swapping of the x and the y, that's the big key feature of inverses. Okay, so we swap the x's and the y's, and then we solve for y. So what should I do first, Andrew, to get y all by itself? If I want to get y all by itself, which one of these things do I get rid of first? Good, so I add 5 to both sides. So I have x plus 5 equals 3y. And then to solve for y, I divide both sides by 3. So I get y equals x plus 5 over 3. And then I change it back to the inverse notation. So rather than y equals, I'm going to do f inverse of x equals x plus 5 over 3. Okay? Those two functions are inverse functions. Watch what happens if I do f inverse of f of, let's go with 2. So, with that composition of functions, if I start by doing f of 2, when I plug in 2, what's 3 times 2? 6. 6 minus 5 is 1, right? So this is going to become f inverse of 1. Now if I plug 1 into the f inverse function, what's 1 plus 5? 6. 6 divided by 3? 2. Do you see how this equaled 2? Because they're inverses of each other. So when I compose them, I get back what I started with. Think of that leather and lace going in, turning into a football, throwing that football into another machine, and it rewinding it back to leather and lace. Yes? Okay, let's flip that over. Okay. Obviously, if we start with a function, it passes the vertical line test, yes? Right? When you take the inverse of something, what it does is it reflects it over a diagonal line. So when I take the inverse of this, it actually ends up looking like this. So this was the original function f of x. This is f inverse of x. Is this a function? No. The original was a function, but when I took its inverse, now it's failing the vertical line test. So the inverse is not a function, okay? But sometimes it is. Like, let's just take, a line. And then when I reflect this over this diagonal, if this was the original function, here's the inverse. Is this passing the vertical line test? Yes. So the original should always be a function. When you reflect it and take its inverse, sometimes the inverse is not a function, sometimes it is. So how could I just look at the original and know whether or not the inverse is also going to be a function? Something called the horizontal line test. Okay? If something passes the horizontal line test like this one does, see how it's passing the horizontal line test? Then its inverse will pass the vertical line test. So there's that swapping again. If the original is passing the horizontal line test, then once you take its inverse, it will pass the vertical line test and will therefore be a function. This one, the original, fails the horizontal line test, and therefore its inverse is going to fail the vertical line test and not be a function. Okay, so a little new test there. If a function has an inverse that is also a function, so something like this, then it is called a one-to-one function. That's a vocab word. Circle that. If you ever see one-to-one function, If something qualifies as a one-to-one function, that means that it's passing the vertical line test and the horizontal line test. Passing the vertical line test makes it a function. Passing the horizontal line test makes us know that its inverse will also be a function. Okay? And remember we talked about no x's repeating itself in order to be a function? If you're going to be a one-to-one function, that means no domain elements. Domain, for those of you that don't remember, are your x's. And no y values repeat itself either. That's how you know something is an even more special function. It's a one-to-one because no x values and no y values repeat. That way it will pass the vertical line test and it will pass the horizontal line test. So that's just a new vocab thing to be familiar with. If someone says, what is a one-to-one function? It means it is a function and its inverse is a function. Okay? So this multiple choice, which of the following is a one-to-one function? So which one has no x's repeating and no y's repeating? Is this one a one-to-one function? Does this have any x values repeating? Yes, so this one's not even a function, never mind a one-to-one function. Does this one have any x values repeating? No, so it's a function. Does it have any y values repeating? Yes, so it's a function, but it's not a one-to-one function. Number 3, does this one have any x values repeating? No. Any y values repeating? No. Then good, this is our one-to-one function. Number 4 is a function, but it is not a one-to-one function. Good? Okay? And last one here, exercise 4. Which of the following represents a one-to-one function? Is this a function? No, it's failing the vertical line test. So if it's not a function, there's no way it's going to be a one-to-one. In 2, this passes the vertical line test. Does it pass the horizontal line test? No, so that's out. Number 3, passes the vertical. Does it pass the horizontal? Yes, that's your one-to-one function. What does number 4 fail? Horizontal line test. Good. So we obviously aren't getting to the last 2 examples, but you should have plenty to do your homework with. No. You shouldn't have done this talking. I'll let you hand them in school. Or do you want me to take a look at them? Okay. So I'm not going to take your corrections like in bits and pieces because when I collect them Wednesday, I just want them all to be in the same pile. I don't want to have different piles at once, so just stick that in your binder, Karen. And I understand that you went to Miss Dawn your whole life, huh? That's who my kids go to. That's who my kids go to. That's where she watches them. Yeah, she told me she knew you.